So this is the experiment number 1 in the analog and digital electronics laboratory. So you are supposed to design, okay, you are supposed to design the circuit as well as you have to implement that circuit, okay. You have to design and implement the circuit of half adder. HS stands for half adder, FA stands for full adder, and HS stands for half subtractor, and FS stands for full subtractor. You have to design and implement the half adder, full adder, half subtractor and full subtractor using the basic gates. It is very important. So using the basic gates. So what is meant by using the basic gates? So basic gates means you have to use either the AND gate, okay, or you have to use OR gate or NOT gate. So by making use of only these three gates, you are supposed to implement the circuit. Okay. So now how to implement the circuit? If you want to implement any of the logic circuit, first you have to design the circuit. So if you want to design the circuit, you have to first get the expression for it. So how to get the expression? So by making use of the K-maps or Boolean logic. So we'll stick on to one method, that is by making use of the K-maps. So now how to get the expression? So how you will be getting the expression? From the K-map. How to write the K-map? By considering the truth table. So how to write the truth table for half adder? So this is the half adder circuit diagram. Okay. So half adder, this is the half adder block diagram. So half adder has two inputs. Let me call it as A and B, and the two outputs, that is sum and carry. Okay. Repeat. I am repeating it once again. So half adder block diagram is this one. So it has a two inputs, that is A and B, and is a two outputs, that is sum and carry. Okay. So therefore I have written A and B as a two inputs in my truth table, sum and carry as my outputs. So it will be easy if you are writing carry first and then sum. Okay, I'll just tell you why I am writing carry first and then sum. Okay. So now, as you all know that we have solved n number of problems related to the K-maps. We have solved the 4 variable also. So now, if there are two variables, what will be the length of the truth table? It will be 2 to the power of 2. 2 to the power of, since there are two inputs, that will be having 2 to the power of 2, that is 4 combinations. So what are the 4 combinations? 0, 0, 0, 1, 1, 0 and 1, 1. Okay. So 0, 0, 1, 1, 0 and 1, 1. Now if I am adding these two bits, 0 plus 0, what is your answer? The sum. 0 plus, always remember, 0 plus 0 will give 0. Okay. 0 plus 1 will give 1. Next, 1 plus 0 will give 1. 1 plus 1 will give what? 2. It will give 2. But what is the binary representation of 2? It is 0 and 1 will be a carryover. So 1 will be a carryover. So this is sum. Okay. This is sum and this is carry. So here 1 plus 0 means 1. What is the carry? There is no carry. So there is no carry, means carry will be 0. Here also 0 plus 1, 1 is the sum output. So what is the carry? Carry is nothing, there is no output, there is no carry output. So carry will be 0. Here 0 plus 0, the sum is 0 and there is no carry. So now 0 plus 0, what is the answer? It is sum is 0. And is there any carry over? No. So therefore let me write carry is equals to 0. Now 0 plus 1, what is output? The output is 1. Is there any carry? There is no carry. So therefore I will write it as 0. Next, 1 plus 0, that is 1 plus 0. The sum is what? It is 1. Is there any carry? There is no carry. So let me write it as 0 here. Next, 1 plus 1. What is the answer? It is 1, 0. 0 is the sum. Okay. 0 is the sum. And what is the carry here? The carry is 1. So this is how you have to write the truth table for half adder. So half adder truth table contains two inputs, that is A, B, and sum and carry are the two outputs. Okay. Just copy down the same thing, whatever I have written on the board. Then we will go for the K-map representation. Okay. Fine. So now we will write the K-map. We will write the K-map. So what is the size of the K-map? It should be, the size of the K-map is only just 4 cells. Because it is having the length of the truth table is only 4. So therefore the number of cells should also be equal to 4. And now towards the left side I will take A, and towards the right side I will take it as B. So A can take either 0 or 1, B can take either 0 or 1. So 0, 0, 0, 0, 0th cell, 0, 1 first cell, 1, 0 second cell, 1, 1 third cell. So this is how you have to represent the number for the 4 cells. Next, so in the 0th cell what it is there? In the 0th cell there is 0. In the first cell what it is there? It is 1. In the second cell what it is there? It is 1. In the third cell it is 0. Now, okay, so this is what I have written the K-map for sum. Okay, now let me write the K-map for carry. So here I write A, here I write B. It can take 0 and 1, it can take 0 and 1. So the cell numbers are 0, 1, 2, 3. Okay, so what I have written in the 0th cell? It is 0. What I have written in the first cell? Under the carry I am telling. Under the carry it is again 0. Here also 0. Here it is 1. See here it is 1. So I am just copying the binary numbers from the truth table into the K-map. So this is the K-map for carry. Now we shall start grouping it. So as I have already told you, how to start from octet, quad, pair and isolated one. Octet will never come into picture because there are no 8 ones, and quad will also not come because there are no 4 continuous ones, and pair. So 2 ones are there, but is it continuous? And I have already told you should go for the diagonal grouping. So pair is also not possible. So therefore you have to go for isolated one. Okay. So this is one group and that is the second group. So now what is the expression for this? What is the expression for this? It is A bar and B. It is A bar and B. And what is the expression for this? It is A and B bar. A and B bar. Just grow vertically and horizontally. I have already explained in the class. Right? So now here also only one is there. So therefore go for isolated one. So what is the expression we will be getting for carry? We will be getting it as A and B. Okay, A and B. So now sum is equals to A into B bar plus A bar into B. Next, carry is equals to A into B. Okay, so this is the expression that you have got for sum and carry. Now, by taking these expressions, I have to write the circuit diagram, and my circuit diagram should contain only AND gate, OR gate, and NOT gate. Right? So I have already got the expression. So by just looking into this expression, I can write down the circuit diagram. So what is the sum expression? I have got it as A into B bar plus A bar into B. Right? So this is the expression that we have got. Write down the bar very neatly. Okay? So now I have already told you you have to use either AND gate, NOT gate or OR gate. Okay. So this is A and this is B. Okay? This is A and this is B. So for if I want to get this particular term, I have to use a NOT gate here. So therefore this is my first term, that is A into B bar. A into B bar. Next is what? A bar now? A bar into B. So therefore I will take it here and I will use one more NOT gate. So therefore I will be getting A bar and I will be using B from here and I will be using one more NOT gate. So here I will be getting what? A bar into B. If I want to multiply it, I have to use the AND gate. If I want to perform the addition, I have to use one more OR gate. So now these two outputs should be added. So therefore you will be getting it as sum. Okay, you have to get the sum. So this is the circuit diagram for sum. Next, after writing this circuit diagram, okay, the very important thing is you are supposed to number it. So I have already explained how to number the circuit diagram in the previous class itself. In the long back, I have already explained how to write the pin numbers in the first few classes. In first few of ADE lab hours, I have already explained how to write the numbers. So just refer the pin configuration of the NOT gate, AND gate and OR gate and write down the pin numbers. So 1, 2, 3 and 4. This is with respect to the NOT gate. And for with respect to the AND gate, I have written it as 1, 2, 3, 4, 5, 6. Okay. And for OR gate, again you have to start it from 1, 2, 3. So this is all about the pin numbers and also the circuit diagram for sum. And what is the carry expression? So carry expression is equals to A into B. So this is what you have got, right? So now let me implement here itself. I just take here A. This is A now. See here. This is A. So I will take it A and this is B, right? So this is B. I'll just take one more AND gate and I call this as carry. Okay, this is carry. And what is the number I have to give? 1, 2, 3, 4, 5, 6 I have already used from one IC. So one IC has 4 gates, right? So therefore 1, 2, 3, 4, 5, 6 already used means you shouldn't use 7. Okay, you shouldn't use 7. So 8 will be your output and this will be 9 and 10. Okay, 9 and 10. You can just refer the pin configuration, you will understand. Already I have explained the pin numbers, how to write the pin numbers for any of the circuit. So this is all about the circuit diagram. So this is very much required in order to implement it. So the design part is finished. So the design part for half order is finished. Okay, the design part for the half order is finished. By considering this design, I have to implement it now. So where you have to implement it? You have to implement it in the laboratory. I'll explain how to implement that. Okay, all those things we'll see later. So first we shall write the circuit diagram for half adder, full adder, half subtractor and also for the full subtractor. Okay, I hope I'm clear with the circuit diagram and also you know how to write the expression by just looking into the K-maps. Okay, just copy down the same thing.